Welcome again to part 2 of the video. Just to give you a recap, we were trying to predict the price of an airline based on certain features, right? In this particular video, we will be doing EDA and some feature engineering. Now, as you can see over here, this was our dataset, and in our dataset, there were about 11 features, and 10 of them were helping in predicting the price of the airline, the 11th feature, right? And that is our goal over here. Now, today we will be doing certain feature engineering on certain features, or in other words, columns, and we will try to pre-process the entire dataset so that we could feed this into a machine learning model. Now, the crux of feature engineering in EDA is that what you have to understand is machines don't understand anything except numbers. In every aspect of machine learning, you will have to convert every kind of data, all kinds of data, to a machine readable format, and that is usually numeric in nature. And here you will soon understand that by the end of this particular video, what you can see over here in this data set, all the features will be converted to a numeric format. And as we all know, machines understand numbers, right? And over here, I've selected about 8 features so that we could start our journey with. Duration, departure and arrival time, date of journey, total stops, edition info, airline, source and destination, and the route. So over here, let's start with our journey with duration over here. So if you were to, as you can see, now there's a problem over here. Let's look at this particular column called duration, and let me zoom in a bit over here. As you can see, this particular column is having the values in this particular format: 2 hours and 50 minutes, 7 hours 25 minutes, 19 hours, so on and so forth. So it is very difficult for us to understand in this particular manner. So we will have to write a function which will take in this particular these values and will convert it into the total number of minutes. That will be easier for a machine to understand. So for example, 2 hours 50 minutes will become about 120 plus 50, 170 minutes, right? So on and so forth. So for that, we will have to write a particular Pythonic function, if you will. So let's start a journey over here. What we're going to do is we'll say, let's say we're going to say define. Again, I'm going to say define convert duration. It will take in a duration as such. It will say if the length of the duration, so what I'll take is I will take in this particular value, and I will look at the length of each of the format. So as you can see, I'll try to say that if the length, let's say we are talking about let's say 2 hour, let's say 15 minutes, I will look at the length of this particular thing. So I will say 2 hour 50 m. This will be the length, and certain features will have 19 hours as such. So it will all depend on the length. So if it is having this format, I will extract the length. So I will extract these features based on this length. I will say wherever this is the length, let's say 1, 2, 3, 4, 5, 6, about as such, I will extract these values and I will multiply 2 with 60 plus the number of minutes to extract the minutes. And in this particular case, it's pretty simple. What we'll do is we will simply multiply it by 60, right? That is the idea over here. So what I would say if the length of duration dot split, I'll use the split method, is equal to 2. What I want you to do is create a new variable called hours, convert this into int format. I would say duration dot split method extract me the first element, and as such. Similarly, I would say for minutes as well, I would say minutes, or I would say minutes as such, int of the duration dot the split method, fetch me the second element, right, and extract me all the rows as such over here. right? And I want you to return me hours into 60 plus minutes as such. And in every other case, what I want to do is return me the duration, right? Fetch me the last element, like extract, like fetch me all the elements except the last one. So I would say duration into 60 as such, right? And this would be it. So let me execute it. So after execution, I'll get something like, I will say data dot head as such. So as you can see, we kind of have not really, like, we have executed this particular cell, but we haven't applied it to our data set. So I would say data, I want to apply this to this duration method over here, so duration column over here. So I would say data, fetch me, drill down to the duration column, and I want you to do data duration and apply this method. Apply convert duration as such, and then I will look at the data set and it will look something like this. So as you can see, all the values have been converted to total number of minutes as such. So this was pretty easy. Second thing is what we're going to do with is a second feature or column that we are going to engineer is going to be departure time and arrival time. These two columns, as you can see over here. So let me add a few more cells. I'm going to be requiring a few more cells. So yeah, let's start the journey over here. So we will have to convert this departure time and arrival time to the datetime format, right? So for that, I would say data, fetch me the departure time column, and convert this, say pandas dot to date time method, and I will have to apply data. Which column do I need to apply this on? So I want to apply this on this departure time, so I would say departure time, right? And I'll do the exact same thing over here for arrival time as well. So I would say arrival time. I'm simply overriding it, right? So I'll say pandas dot to date time data arrival time as such, right? And let's see what our data type is going to look like. Data dot date types. So it's going to give me, right, so we have successfully converted the departure time and arrival time from object to a datetime format. Now we can extract the hours and minutes from the departure and arrival times. For that, we will have to say data, let's create a new column or feature called departure time in, let's say, hours, right? So I'm sorry, let me say in hours. I'll say data, go to, essentially saying go to the departure time column, right, and convert this to datetime.r method as such. I'll simply copy the entire thing and I will say departure time in, let's say, in this time minutes, right? And data departure time, convert this into the minutes format. I will say .minute as such. Similarly, I will copy this. This time I will do this for arrival time. Arrival time in hours, it should be going to drill down to the arrival time column and convert this into R. And again, do this exact same thing for arrival time. I'll say arrival time date time. Use the minute attribute as such. Once you do that, you would say something like data.head, and this is what you're going to get. So essentially, you have created four new columns as such. Departure time. Oh, excuse me. I guess this was incorrect. I should have mentioned minutes over here. Right, and now it should work fine. Let's see. Yeah. So you have essentially created 4 new columns, which is going to extract the departure time in hours, departure time in minutes, arrival time in hours, and arrival time in minutes as such. Right? So far we have successfully extracted these values, and to be honest, we don't really need these departure time and arrival time columns, so we can simply drop them. So to drop, we would say data drop method. I would say I want to drop all these elements inside this list. So departure time and the arrival time. And since I want to do this column wise, so I would say x is equal to 1, or you could say x is equal to column, both would work. And I'm saying in place is equal to true because I want to make these changes permanent. Once you do this, you will get something like data.head method. This is what you would get. You just got rid of departure time and arrival time column, and because you simply don't need them, right? And we can get rid of these 2 extra cells as well, right? Then now the next feature that we're going to engineer is going to be the date of journey method over here. Let me add a few more cells. So as you can see, we are interested to look at the date of journey. So let's look at the date of journey method column. So all right, so over here is going to be our date of journey column, and we are interested in extracting the months and the dates. So these are the days and these are the months that we're interested in, and also the year. But there's a problem with year. You would notice in a moment, I'll show you that all the data points have the same year. So this is essentially the data set of the year 2019. So we can just do without it as well, right? So to find the unique values of the year, first we'll have to convert this into date time format, and then we can proceed with it to find the unique values of year, right? And then you would notice that only unique value of the year is 2019, so we can ignore that particular fact, right? Because we don't really need it. So right, so first what I'll do is, what's the date of journey? I'll say data fetch me the date of journey such, I would say pandas dot to date time to underscore date time method, saying data the date of journey. As such, and I would say data.head. So I have converted this date of journey to a date time format over here. Now what I'm going to do is I will show you the unique values. So I would say data of journey, let's say date of journey. Now since I have to write it again and again, I will simply copy this part so that I can reduce those tiny part. So I would say dt.year, and I want to fetch the unique values. So I would say .unique, and this is what we'll get. So since we are only dealing with 2019, we might as well not touch that part. Like we can create a new column. So my goal over here is to create new columns with the day and month in it, not the year, because year is going to be common. So we can, to avoid redundancy, we are going to eliminate that. So we're going to extract the month and day from the date of journey column over here. For that, we will take use of pandas. We will say data, right? I'm going to create a new column called day. I'm saying is equal to data of journey, right? Dot dt dot day, switch, right? I will copy the entire thing. I will paste it over here. I'm going to create a new column called month, and over here I will change the attribute to month as well. So what you are left with is data.head, and this is what you would get. So let's see, yeah, over here you just extracted you created two new columns called date and day and month, And yeah, we've extracted the number, the date and the month over here. So just to make our life easier, since all of the columns are starting with a uppercase letter, I will change it here as well. So I will say capital uppercase D and uppercase M over here, and I would have executed again. Right, this looks better. Now we want to, since we have done that, we can go ahead and drop this date of journey column. We don't really need it anymore. Where is it? Date of journey. We don't really need this thing because we have done the EDA. We have engineered 2 new columns based on this particular column. Now that we don't need it, we will simply drop it. So we will say data dot drop, right? Sorry, data dot drop. Fetch me. I want to. I want to say date of journey axis is equal to 1 because I'm dropping a column wise, and I want to keep this change permanent. So I will say in place equal to true. I will say data dot head such. Right, so we have successfully deleted the date of journey column, right, as such. Now let's go ahead and delete these 2 cells. We don't need them. Right, the next feature or column that we're going to deal with is going to be the total stop. So let me add a few more cells just in case we might need them. It's going to be, now let's look at the total stops, right? Where is it? Okay, right. So now this is again an interesting part over here. You will notice that total stops is first of all, it's a object data type, and it contains these values: non-stop, 2 stop, 2 stops, similarly 1 stop. It could be anything. So we want to convert this to 0, this to 2, this to 2, and if there this to 2, and if there is let's say 1 stop, we would want to convert that into 1 such. For that we will have to write a method. So let's do that. We will go ahead and say let's look at the unique values first. So we will say data, let me zoom in, total stops as such, and we will use dot value counts method. It turns out there are about 5,625 values for 1 stop, followed by 3,491 values for non-stop, so on and so forth. And interesting, there's only 1 data point that has 4 stops in it. So we would want to create a map as such where we could get something like 1 stop is getting mapped to 1, non-stop is getting mapped to 0, 2 stops is getting mapped to 2, 3 stops is getting mapped to 3, and 4 stops is getting mapped to 4 as such. For that, we will use the map method inside available in pandas. So let's do that. We will say data, we are interested in total stops, right? And I would say data total stops. I want to map, I will use the map method, right? And I would say, as such, I would say non-stop to be converted to, again, make sure that you are, it is case sensitive, so non-stop must be all lowercase. So I would say non-stop, map it to 0, and then make sure 1 stop is getting mapped to 1, 2 stop is getting mapped to 2, similarly 3 stops is getting mapped to 3, and do we have 4 stops? Yeah, we do have 4 stops, so we'll add that as well. We'll say 4 stops is getting mapped to 4, right? And let's execute. Right, it has been executed, so let's have a look at our head. Right, let's look at the total stops. Yeah, right, so we have successfully converted our non-stop to 0, 2 stops to 2, 2 stop to again 2, 1 stop to 1, and so on and so forth. Right then, so yeah, So let's get rid of these extra cells. Right. Now let's go to additional info. Let me add a few more cells just in case. So let's try to explore this particular feature as well. For that, I will say data, go to additional info column, and count me the values. I would say value underscore counts method, and let's see. So you would notice that the majority of the values have no info over here. So we might as well simply discard this column, as it doesn't seem to have provided any valuable information, right? 8,344 have no info, plus about 3 values over here as well. So since a majority of them have no info, it will be very, very, very difficult for us to understand, do some feature engineering based on the rest of the available information. The best thing to do here would be to simply drop this particular column. So we would say data.drop method. I want to drop additional info, such, along the column, and I want to make the changes permanent. Say data.head, and this is what I would get. Let's see, have we successfully done that? Yes, we have successfully done it. There, I can't see any additional info. Right, perfect. Right, now that we have reached over here, we can go and have a look at different data types, right? Because we have successfully converted all these values into numerical values. I just want to find out which all data columns are having object data types. So for that, I would say data.select data types. Let me zoom in a bit. So data.select underscore data types, and I want to select only the object one. So I would say object dot columns. Fetch me all the columns which are having the object type, and it would give me airline, source, destination, and route. Perfect. So we will have to deal with them first. Now, before we do any of that, let's try to find the relationship between the price, the airline, source, destination, and total stops. Right, so I will write a simple for loop where it will create a visual representation, and from that we will be able to understand the relationship between the price and airline, source, destination, total stops. For that, I would say for I in this particular list where it will contain airline, source, destination, and total stops. What I want to do is, first of all, I will create a figure, a canvas if you will. So I want to say figure, where I want to give the fig size to be equal to, let's say 15 by 6 dimensions as such. Or yeah, this looks fine. Yeah, fair enough. Let's make it for, okay, 15 by 6 seems fair. Then I would say I'm going to use the cbond library. I'm going to say cbond.countplot data is equal to my data frame, that is data again, and x is equal to I as such. Here I'm going to create a canvas, and the name of the canvas usually is going to be axis or ax, so I will use that as well. I would say axis is equal to ax dot cbond, I would say cbond dot countplot x is equal to I, data is equal to data dot sort values, and I want to sort the values by price, and ascending is equal to true. is equal to true as such, right? And now if I were to simply execute this, there will be a problem. You will notice the problem would have been, see, all right, so you know what, I'll show you the problem first. I would say dot type layout, plt.show, let's say print, like I want to give some values in between. Let's say print \n as such, easier. Right, so let me execute this first. You will understand the problem. Right, so there seems to be error. All right, matplotlib has no, oh, I'm sorry, dot tight layout. Right, so let me execute once again. Right, so this is the output over here, and you will notice, let's see, look at the problem. The problem is, even after a tight layout, the ticks are overlapping each other because they have very, very long names. To overcome that, I would want to rotate the ticks. These, by the way, these are ticks. The name of these values like Go Air, Vistara, TrueJet, AirAsia, so on and so forth. These are these are called ticks. So I would want to rotate them, right? So I will have to say ax dot set x tick labels. So I would say x tick labels. Let's say axis dot get x tick labels, get x tick labels. Again, these are the inbuilt methods, and I would want to rotate them 40 degrees, let's say 40 degrees over here. Let's say HA is equal to, let's say, right. Now if I were to execute this, there's again an error. Text has no, oh, I'm sorry, it should be rotation, I guess. Yeah, it's rotation, right? Let's execute. Right, so as you can see, this is my output, and all the ticks have been rotated 40 degrees anti-clockwise. So here, these are the visualization. So as you can see, again, this is the count plot. So what I'm trying to say is that Jet Airways has the highest number of passengers, followed by Air India. They seem to be very, very close. Go Air has the least, and as you can see, multiple carriers Premium Economy is having the lowest over here, and Jet Airways Business and Vistara Premium Economy don't seem to be having any, or if at all, right? And it's very difficult to see. Then similarly, looking majority of the people, if we were to talk about source, majority of the people are coming from Bangalore and Delhi, and they are landing, majority of them are landing to Delhi and Cochin, such the destination, and the majority of the people are having at least one layover or a stop in between, right? Followed by 0, and followed by 2, and then 3 over here. So this was kind of an insight and exploratory data analysis using the visualization part. So let me get rid of the extra cells. Let's go to airline now. So let me add a few cells just in case. Right. Now I will try to explore this airline column as such. So for that, I would say data, let me zoom in, data airline dot value count. All right, perfect. So it says that as you can see, majority of them are actually using Jet Airways, followed by Indigo, followed by Air India, and so on and so forth. So again, this was kind of reconfirmed by this visualization plot over here, count plot. It is not very surprising as such. Now I would want to get this insight from the visualization perspective. For that, I will write the code. I will say, first of all, I'll create a figure or the canvas, and I will say the fig size being is equal to, let's say, a tuple of 15 by 6, stand 1. Then I will say, again, the exact same thing I would do. So for that, in this particular case, I would say AX is equal to cbon SNS dot bar plot, right? And I'm gonna say x is equal to the airline, y is equal to the price, sorry, and I want to say data is equal to data dot sort values search, and I want to sort the values by price. It's the same thing I'm doing, just in a different manner. Sending is equal to false. Now the exact same thing I will do over here. Let me copy this part over here. I don't want to type it again, so yeah, copy this over here. Right, let's execute this. Hopefully it should work. Yeah, it is working perfect. So I'm looking at this data, this particular data in a visualization perspective, and it looks good to me. I will do the exact same thing, but this time I've created a box plot of airline versus price for getting the statistical analysis. For that, I would say create a figure. Again, I will simply copy this part over here. Now I want to save some time. I would say png.figure fig size equal to 15:6 canvas, and then I'm gonna use a box plot. So I would say cbond.boxplot. I would say x is equal to airline, y is equal to price, data is equal to sort values by price, sending false, and then rotating the text and showing it. So I will get something like this. So as you can see, Jet Airways is having a lot of outliers, and similarly multiple carriers is also having a lot of outliers. By the way, these dots over here, these are the outliers, as you can see. So to get a statistical summary for this particular plot, box plot, I would have to write, we'll say data, and I want to group the entire data frame by let's say airline. I want to use the describe method to get the statistical summary, and I want to get it of price value, and I want to sort values such according to the mean, and make sure that you are displaying it in a descending or at least a non-ascending fashion. It's as such, and you get something like this. So over here, as I can see over here, this is the easy part that I can see, and let's try to decode it, right? So over here again, it's a huge mess, if you will, and the mean of Jet Airways is about 58.535 thousand, 58.3 thousand, and followed by Jet Airways. Again, this is sorted in descending order of mean, as you can see. I've taken the mean because I want to look at the arithmetic mean, just to get an insight into the let's say the most expensive airline on average. Now, as you can see, all these data points are of object data type, but our machine cannot understand them. Our machines cannot understand anything except numbers. So it is our job as a data scientist to convert them into a numerical format. That is where your encoding will come into the picture. Now, there are different kinds of encoding. For this particular purpose, I will use one-hot encoding because there are not many values as such. So I would say I will say airline. I'm going to create a new data frame called airline. I would say airline.pandas.getDummies. Now, getDummies is a method to apply one-hot encoding onto a said column. So in my case, it is going to be airline. So I would say airline, and I would want to first say draft first is equal to true, and I would say airline dot head, and this would be my output, as you can see. right? Pretty straightforward. Now I would want to concatenate the airline, this airline data frame, with with my main data frame. So I would say data is equal to pandas.concatenate. So I would say concat method. Given a list, first I would want my airline to be at the last. So I would say data followed by airline. And since this is supposed to be done along the column wise, I would say x is equal to 1. Right, so you would get data. So over here I would say data dot head, and this is what you would get. So as you can see, slowly we are converting all the object data types into a numeric format. So now that we have done that, we can get rid of this airline airline column over here, right? We don't need it anymore. So we would say data dot drop. I want to drop the airline, zoom in, airline along the y-axis, or in other words along the column, and I want to make the changes permanent as such. Say data dot head. This is what I'm left with. Wait, yeah. Now we have to deal with source and destination as well. So let me add a few cells just in case. Right. Again, let's try to understand understand the value counts. So first I will look at the value count of source, and then I will look at the value count of destination. So I could simply write the value counts twice, or I could simply create a for loop. So I would say list1 is equal to, it contains the source and destination, source and the destination as such. I would say for L in this particular list1, what you do is print me the data L, right, dot value counts as such, and I want to give a break as well. So I would say something like n, and yeah, this is what you get. So over here, the source, again, this is reconfirming a fact. Earlier also I used the count plot to answer this. Delhi it has the most most of the people in this particular data set are starting their journey from Delhi, followed by Kolkata and then Bangalore, and most of them are having their destination as Cochin, then Bangalore, followed by Delhi, so on and so forth. Right, so we have to convert this. We have to convert these values, Delhi, Kolkata, Bangalore, Mumbai and Chennai, to a format, a machine readable format. Again, we will be using one-hot encoding in this particular manner. So I would say pandas data is equal to pandas.get dummies, and I would say data is equal to data columns is equal to let's say columns equal to, again, list1, because I have done that before, and I want you to do is drop this is equal to true. Now if you've done that, I would say get data.getHead, fetch me the first 5 rows, and this is what you would get. So you have successfully converted the source and the destination into a numerical format as such. So you're getting source, look at this, source Chennai, source Delhi, source Kolkata, source Mumbai, similarly destination Delhi, destination Hyderabad, destination Kolkata, and destination New Delhi as such. Right, and this is what you get. Right, and the last feature that we're going to engineer is going to be the route. So let me add a few more columns as such, just in case. Now this is going to be interesting. Why? Because look at this particular route over here. Okay, so just to make it clear, I'll explain to you just a second. I will do route is equal to, let me create a new one. I will say route is equal to data route, right? You will understand why I said it's interesting. Look at this. Here, again, this is kind of interesting because first of all, there is special character. That's A. That is this arrow over here, this special character that you deal with. And then you will notice that there are maximum 4 stops, right? So why? How did I know that? Well, look at this. I would say route, excuse me. Yeah, we'll say data total stops, total value counts. You will notice that majority of them, a total, there are about 4 stops as such. So there are maximum 4 stops for a flight, and hence the number of routes would be 5. Why? I mean, if there are 4 stops in between, so let's say there are A, B, C, D, E, and F, right? If this is your source and this is your destination, you will have you will have maximum 5 routes in between. So the number of routes maximum could be 5. 1, 2, 3, 4, and 5 at best. So it is in our best interest to convert them into a machine-friendly format. So let's do that. So the idea here is going to be pretty simple. I would first of all say I'm going to create 5 different routes, or in other words 5 different columns which would encapsulate these values. So I would say route route 1, I'm sorry, I'm saying route underscore 1 is equal to route convert this values in string format and split it using this particular special method. So let me copy this one over here, copy this, place it over here, and split it and extract the first element over here. This is the first element. So you will get after splitting, you will get a list. So you will get, let's say, Bangalore and Delhi. So you will get a list containing 2 elements, Bangalore and Delhi. If you were to splitting using this thing, and this is the value that you have, CCU, IXR, BBI, and Bangalore, you will, in your list there will be 4 elements, and I want to extract the first element, so I will say 0 as such. I will copy the entire thing over here. Since there are maximum 5 routes, I will create 5 of them, right? And I will say route 2, extract me the second element from the list. For route 3, extract me the third element of the list. Sorry, 2, index will be 2. So for the route 4, extract me the 4th element from the list, that is index 3. And for route 5, extract for me the 5th element from the list, or the element having index 4 as such. After you would have done that, you will get something like route.head, something like, let's see how this works. Oh, there is a problem. Let's see. Length of values does not match of index 2. Right. Right. Okay, so I got the problem. What the problem was, turns out that we have to use the str method over here. It's let me convert them all over here. str. Hopefully it should work now. Let's see. All right, perfect. It is working perfectly. Now, since this is done, I would want to change this value, all the NaN with none, just to make it look better. So I would say route.fill NA, fill all the missing values with none. Right, sorry, just none. Search and keep the changes in place by saying in place is equal to true, such. And I would say route dot head once again, and oh, again a problem, just a second, must fill a missing value. Oh, my apologies, I have to say this is in missing in quotes, and this will get perfect. Now, as you can see, there are lots and lots of different values. So over here, it may not be very prudent to use the one-hot encoding. For that purpose, I will be using the label encoder. So I would say from scikit-learn pre-processing import label encoder. Then I will create an instance of label encoder. Then I would write for I in the range of, because there are only 5 of them, I would say 1 to 6 column is equal to route underscore followed by this particular number, that is plus str I, right, because 5 of them are there, 1 just 5. Make sure what you're doing is route column is equal to bit, I would say label encoder dot bit underscore transform such route column, right, and towards the end what you do is route dot head, say yeah. So you have successfully implemented the label encoding as well. Now we don't need this route method, so I will say route dot drop drop this value called route, do it along the column, so 1, so and in place is equal to true. Let's say route, get something like route dot head, and this is what you would get. Perfect. Right, and towards the end you may want to concatenate these values to your main data frame. So I would say data is equal to pandas.concat the list data and route along the x-axis, so along the column, sorry, and in place is equal to, do we need, no, we don't need in place equal to, and you will get finally something like head. Right, perfect. So you have converted almost all the columns into the in the numeric format, and since you don't need this route column anymore, so you can simply drop it. You could say, you would say something like data dot drop route and axis is equal to 1 and in place is equal to true. Finally you would get data dot head as such. Perfect. So this is your cleaned data set, and you can see that all of the columns have been converted into numeric format. In the next part we will be building the machine learning model, but before that we will have to do some scaling as well, right? So it is going to be very exciting in the third part, and I hope you like this video. Be sure to give it a thumbs up and be sure to subscribe as well. So till next time, cheers.
Project Pro, the only solution for solved industrial grade projects.